Hi, my name is Anand Balaram, B. Anand in Don Bosco roles, probably more known as Bumble to friends. But it's my pleasure to introduce my namesake, my earliest tennis partner, and of the batch of 68, there's three of us who played tennis under the tutelage of Coach Ramarao in South India, hardcore tennis in Bangalore. And we split, we graduated in 68, went our separate ways. Anand got his BTech in IIT Kanpur, and then came right away to Rice in Houston, where he got his master's and PhD. Joined Bell Labs, the favorite hunting ground. Was the first primary software architect for the first 32-bit microprocessor, and did a stint with Data General. Decided to start his own company. First one was Banyan Systems, 1983, I think. And they were into enterprise networking, which is the forerunner for today's open internet. Went public in 1992, did really well. First Indian American of our genre who went on to become an entrepreneur. Didn't have enough of that. So I think it was 1993, started his next company, Responses, yes. That was in internet networking again, and in internet marketing, things of that nature. Went public again, did a double whammy, got acquired by Mr. Ellison of Oracle, so then decided to be a serial entrepreneur. Whole bunch of startups thereafter, and today he is a venture mentor or startup mentor for the Indus entrepreneurs. TAI is called, Silicon Valley, which is where both of us are from. And he's involved with a whole bunch of companies. I think he's got a 25 portfolio, and he's into all kinds of things, including alternate health. And without too much further ado, AJ, take it away.
Thanks, Anand. So actually, I'm Anand, he's Anand. I have told you a joke about two Anands going to a bar. But I won't do that. But instead, I tell you a joke about two AIs going into a bar. So they go to the bar, the bartender asks, what do you want? So the first AI says, give me a tall glass of knowledge. The second AI says, I want one of the same but with a shot of reality. The pretty girl sitting in the bar looks at both of them. Guess what she says? Bartender, first of all, the first thing is she's looking around, gives them both a glass, and this is yo. I'm going to give you this glass so you can hallucinate. The lady looks at this. What's the limit? I-A-O. So that's the limit of AI. And as Anand mentioned, I typically give a talk to startups on how to create a really successful startup, having done that 5 times. But then for this audience, the theme was AI. There's very illustrious speakers who preceded me in terms of how AI is being applied. So I thought I'd sort of weave in a whole history of AI. Many of you may not know some of these things. I thought it would be interesting to understand where AI came from as I was building the various companies. Anyway, my talk is going to be about 3 decades of evolution of AI. And I think the first quote is sort of very apropos what our rector had mentioned. Success is all about not you, but how do you give it back to the community at large. And how do you really have an impact on a much broader set of people. The second quote is about what's happening in AI right now, and I'll bring it in the context later. And the third quote, again, I'll bring it at a later time. So, I started my first company 4 years after I did my doctorate at Rice University. And one of the best things I said was, if I'm going to be an entrepreneur, I'm going to apply my engineering principles. I'm going to approach and say, what makes an entrepreneur successful? And so I basically came up with the idea that there are three basic tenets to creating a successful entrepreneurial company. One is there are always inflection points happening. And we heard some of the various medical discussions that there are so many different inflection points happening and people capitalized on it. And we got to recognize that there's always something happening. And the true entrepreneur, an inflection point happens, the incumbents are a danger. And that's when new companies evolve. And that's where we need to recognize. Second is, when you're doing a company, there are 100 other people doing a company, especially in these days. So what makes you different? What is unique about you? You've got to create your own unfair advantage. And the third is about luck. Everyone says, oh, this guy was lucky, another guy is lucky. No one is lucky. The smart ones are the ones who recognize that luck is staring at their face. And that's what serendipity is all about. Luck that is recognized. When I did my first company in 1983, I was one of the very first Indians to start a company. And the inflection point was the advent of the personal computer. It was being ubiquitous everywhere, it was happening, but yet, again, someone mentioned Moore's Law. We realized that with Moore's Law, this personal computer is not just going to be a simple computer. It is going to double in capacity and power every year, and it's going to be the most powerful system. And you see that in the phone that you have. That's a lot more powerful than the IBM mainframe that used to be there 20 years back. So that was the inflection point. So he said, how do we connect the personal computer? It's not going to be sitting by itself, it's going to be part of a much, much larger enterprise system. So how do you really build an information exchange across the enterprise system? And the advantage we had was that we actually recognized that a lot of this technology, this sort of research had been done by Xerox. There was a lot of base of background in the Unix operating system. So we leveraged all that. So we didn't think personal computer, we thought big enterprise systems 10 years ahead and leveraged the technology from there. The serendipity point was that we built all this, we had some good customers, World Bank was a good customer, we went into all the financial services and they said, no, we don't buy computing equipment from some unknown startup, we only buy Big Blue. And that's when there was a serendipity point where we suddenly realized we should be pushing this as an enterprise computing system. We said we are a networking system that complements Big Blue. And immediately they realized, oh, and that became a huge success for the company. I went IPO, one of the early successes of internet networking companies. One of our classic use cases was the Marine Corps in Desert Storm. They actually had Banyan mines networks move from place to place as they moved the army. Interesting story about Banyan. All of you know what a banyan tree is. All around from Araya and from Calcutta, the big banyan tree. I came up with the name Banyan as nature's network. Went to one of the top marketing gurus, along with the two co-founders who were not Indian. And the guy said, lose this ethnic name. It's too ethnic. Interesting enough, I said no, we should stick to it. And every one of our customers over the years loved the name because they said that symbolizes their good feeling. Because they all used to go to Hawaii and Maui has a great banyan tree. And so banyan always simplified really good holiday, and at the same time it was all about networking. So this is what our promise was, and we talked about it in early 83s about the whole network office. So let's get to AI. So where did AI get started? AI got started early days 1975. In fact, the first approach to AI was knowledge representation. And knowledge representation, how to do something with it. And Chandru talked about diseases, this was much later. But in early stages, one of the very first products was mycene, which basically had a representation of all bacterial strains and 450 rules of how to take those bacterial strains and then provide a diagnosis for them in the 70s. Then the second aspect of AI was logic-based relationships. A means B, B means C, so A means C. These logic relationships were basically derived and were used in terms of deductive reasoning for scheduling, various kinds of things. And the language that was used in those days was Prolog and Lisp. And in fact, the earliest aspects of AI with hardware assist was Lisp machines that were built during that time period. But this was very intractable. It really did not grow. And we call it, there was an AI winter. In fact, it's a classic thing where, in 5 years, nothing happened in terms of AI because everyone said or it's really not, it's nothing, there's no promise here, it's very hardcore, you have to program every one of these things, it's very difficult. And this was a very difficult programming system to build at that time. But that didn't last. During this time, I actually had my second company, which was an email company, one of the very first Windows email companies. And then I moved on to my third company. This was all about the internet. Internet was growing, e-commerce was growing. It was the very early days of e-commerce in 1988. And one of the things we saw was that, hey, there's a big need for marketing. But marketing offline was a very expensive business. It's a $165 billion business. Those of you in the States during those days, you remember this thick Sears catalogs and JCPenney catalogs that you used to get. We sell twice a year, very expensive to produce, and by the time we got it, it was out of date. And we said, hey, what can we do? No. What was my unique experience? 15 years of working with email through all the different systems there. How do I leverage it? So let's use email as a fundamental basis for online marketing. And with email, I can market to one. I can market to each one of you in a very different way based on this one dynamic marketing system. And that's what we built. We built a personalized marketing system. We were used with a lot of major retailers, major airlines. Had very good traction. I went public as a unicorn in 2000, and then Oracle bought it, and it's now actually Oracle's marketing is the product that we had built. So it's good. I think the product lives on even today. Even today, when you get mail from United or Sears, I think it's all our product, or Under Armour, any of these are our products. So what is happening in AI at that time? The next 10 years of AI, the first aspect was machine learning. And in fact, David talked about how you can get data from looking at large amounts of data, you're able to learn patterns for the PD diagnosis. Early aspects of this was that in terms of machine learning, we learn the patterns. But the first major development at that time was neural networks. Neural networks try to mimic the brain. So literally the way how the brain receives input, goes forward, and then there's a Bayesian probability. It's exactly how we think. When you look at something, we're not sure about how we get to a decision, but we have a variety of ways and the brain thinks very fast and gets to that decision. That's what neural networks did. And they used to predict stock prices and automate trading. And the next advancement was intelligent agents. Now, how many of you remember IBM Deep Blue actually beat Gary Kasparov in a chess champion in 1997? It was based on the whole concept of autonomous agents based on neural networks, which actually went a lot more moves ahead of the chess game than what a human could do. And that's how it beat Gary Kasparov. Nowadays, nobody even tries to play that because machine will always beat you. And then robotics, early aspect of robotics. One of the early foundations of AI, and it's not very important, is this concept called SVM algorithm. The reason I bring that is we think it is something you forget about easily, but it is a very fundamental change. Now, very simple idea how to explain this. And I'm going to explain this. If you take the digits 0 to 9 and ask people to write it, across this entire audience, there are so many different versions of how it is handled. How does a machine detect that that's a 0, that's a 1, that's a 2? Well, that's what it is based on the SVM algorithm. It actually had a whole concept of using hyperplanes and the number of attributes about an object and detect that object. And David mentioned the concept as part of the PD, he had good analysis, the test is positive or negative. That actually is the SVM algorithm application, where you have lots of data, lots of different parameters, but you're able to say classify the 1 or 2, whether this or that. And one of the other aspects of it was fraud detection. Neural networks then evolved into multiple layers of neural network. That's called deep learning. You have heard of deep learning systems, smarter neural networks, where there are multiple neural networks and multiple planes that eventually, and this is where neural networks are much smarter now than the brain, and they could get to an answer. Two early advances in that time was AlexNet, which is a visual recognition system that could recognize objects, and DeepMind, which is a company which actually could take pixels and play Atari games in a very successful fashion. AlexNet the project lead was Jeffrey Hinton. The founder of DeepMind was Dennis Hassabis. Now, what do I mention these names? Anyone else guess? Exactly. Jeffrey Hinton won the Nobel Prize for Physics in 2024, and Dennis Hassabis won the Nobel Prize for Chemistry in 2024. Their work was done that far back in terms of the early years, and they are the early pioneers in terms of what happened. By the way, interesting side story, Jeffrey Hinton resigned from Google a year back because he thought that AI was being misused and that it can never be controlled. And there are actually interviews of him, you can go online and find out about that. Also, another well-known company, NVIDIA. NVIDIA launched its first GPU in 1999. And the original basis of the GPU is a geometric processing engine to show bitmaps graphically in big monitors. 2006, they decided, let's try to use this for parallel processing. But one smart move they did, again from a technology point of view, is that they introduced the Coda platform to build parallel programs. To this day, why has NVIDIA never been dislodged as the solution for as they bring the AI? Is because the Coda platform is so inbuilt, and that's the only way to do parallel programming. There is so much of algorithms that have been built on top of Coda that you can never really move, and they're not going to use Coda to support something else. So, just a point of reference, time of NVIDIA, if you put $1,000 in NVIDIA, you'll be worth $5.5 million now. That's all learn and read. The next phase of AI was when we started doing this natural language processing. We started training on large sets, and this is where the first GP2 came, and Google Bird came. And these all were actually adding more weights. And the natural language processing, they actually started processing words and sentences and adding more weights, and you can actually fine tune. And I'll come back to really how this evolved. But this is the first entry into modern AI, today's AI. The other useful development was computer vision object decision. If you remember the late 80s, the 2018 time frame, the self-driving, not the self-driving cars, but the cars would basically let you stay, Tesla would let you stay in the same lane or maybe lane changes, or the one that kept you 4 cars behind from the previous car. That was all done through computer vision AI. Two major drivers during that time was the fact that you had two open sources, which then started doing a lot of people started building applications on that. TensorFlow was a deep learning framework. Hugging Face was a way to do this natural language processing and characterize it. It was the first step towards what is now called as transformers. So today, where are we? We're really in a state where we're getting ready to blast off in terms of AI. Bringing it back to where I am now, I did my 5 companies, realized that a lot of companies getting started, I'm done with what I can do. I think there's a lot more smarter younger kids than me. And that's when I said, how do I leverage this? I'm not going to be able to start my own company. So, 3 years back, I said, okay, here's the inflection point. Let's figure out, instead of trying to do your own, start working with a bunch of young companies. And that's what I started doing. My special expertise was that I had 35 years of entrepreneurship, did about 40 rounds of financing, and all the scars in the back. Knew what to do wrong, what to do right, and yet, young kids not necessarily don't listen to me, but at least I say, here's what you do. And one interesting thing was this. The serenity point was early days, everyone used to come with an idea, I said, oh great, I'll come spend time with you, I'll give you money. Then I realized I was like a kid in a candy store, I had no discipline. I lost, I did 2, 3 investments, bad investments. I started putting more discipline. So I have 3 criteria now for looking at companies. One is that you have to have a product. You can't be funding someone building something. Nowadays there's so much of tools available that you should be able to build a product and you should be able to get your friends and family to fund that product. Second is that you need to have some customers validate the product. However much the technology, someone has to say, I pay for the product, and I should be able to talk to these customers. So that is a very important point. We actually look for paying customers and referenceable customers. And then you also say, how are you going to grow? How are you going to grow next year? A lot of people say, oh, the market cheap, I'm going to get 10% of the market. That's not going to work. You got to actually have very specific thing. And by the way, this, when you start putting this requirement, it was amazing how the entrepreneur you first talk to would come around and say, yeah, I thought about it, and here's how we're going to do it. So we need to have a very clear idea. And today I'm part of the, as Anand mentioned, I'm part of the TI Silicon Valley Angel Group. I co-chair that. I do investment directly. We have investment in SaaS, AI, platforms, etc. And I'll come back to some of the portfolio companies. So getting back to where AI is the last 4 years, this is the major advance we've been hearing about. We heard about ChatGPT being talked about many of the speakers here. What is ChatGPT about? Well, there's a very seminal paper called Attention is All You Need. The main guy was an Indian guy, Vaswani. What does this mean? Very simple idea. It says, when you look at a string of letters, okay, you typically everyone looks at a single letters as a sequence. That's what Google search does. It looks at a string and it finds where the string is and maps it and finds out the best source for that string. In this, what you say is each word requires special attention. So you use something called feed forward transformer network, feed forward networks, and you build value and says, where all can this word occur? All through the domain of knowledge. The bigger the domain, the more value and token you have in terms of that word. So that is what really happens in terms of when you talk about the whole concept of large language models. You've taken the universe of knowledge, you've tokenized each word. So when you pick a newspaper, they take every word in the paper, and again, they ignore the simple words, every word in the paper, figure out what is the context, and build some value on top of it. And so the more words you have and the more context you have, the bigger the knowledge base is. GPT-3 has 175 billion parameters, GPT-4 has 10x, 1.8. So think of it as this. What has happened, it took a very simple approach and took every word and said, what all the context that word can appear in, and which word does it appear, next to it, how many words are 2 words away, how many words are 3 words away. When you build that level of knowledge, actually, if you look at it, if a human had that level of knowledge, you can ask a human any question and they'll be able to answer because they're able to tap it. We do it in a very small way. And that's really what it is. So when you ask a question, out of any of these large language models, like ChatGPT, GPT-4 or Claude or any of these ones, it basically has a huge amount of knowledge and then takes a very simple approach to the query asked and goes and says, okay, where's the best match of this? And that's a very simple approach to how we look at these large language models, and that's where it is generative. Because it's generative, because every time you ask a question, it adds to it. When if you go to ChatGPT, you can reply and say, hey, this is a good answer and a bad answer. It'll add to the weightage. So as it's interacting with more and more users, it's becoming more and more intelligent. It's scary, but that's exactly what's happening in terms of the whole. Yeah. And then we started applying it to video and to audio. In fact, I was very amazed that Father Rector, he said he created a video with the AI product. And that's what there's DALL-E for image creation, there's a lot of these products. And that's the beauty of what is happening with AI right now. So today, where are we? The future is unlimited. The foundations of the rocket ship is there. All this. We talk about deep learning, we talk about computer vision, we talk about natural language processing and machine learning. There is this huge body of knowledge of the world has actually been codified into these big repositories and is continuously adding to those repositories. So any question you ask, it figures out and says, okay, where are all these occurrences of this world, which is the whole concept of tokenization, and says, okay, here's the answer. That's as simple as that. And that, by the way, this thing requires a huge amount of computing power because that knowledge base will continuously keep growing out there. And that is why today AI is all about, as the friend Anand will say, it's about power and water. Water for the cooling, power to keep it going. But that really is the potential for AI, that you can slowly improve it. And we had great applications from all the doctors in terms of what can be done. So we essentially see that AI is going to be the extension of everyone. By the way, I really think that more and more companies are going to, with the power of AI and everything in the AI office, you're going to come back to the office. I think a lot of companies are already getting that because the interactivity with others and the interactivity with all the AI elements, everything else, you're going to go to the office of the future. So what is the future trend? There are problems with AI. The promise is, you're getting very vertical models. I have companies that are very specific in insurance, you get very vertical, smaller language models. He's now, as you said, working with text. These are examples of working with image, audio. And science is amazing. There's protein discovery, there's a lot of drug development, everything. There is a big worry with AI. Disinformation, big problem right now. Fake news. There is hallucination with AI. Infringement of copyright, infringement of data privacy. So if you remember the original code I had given you, but AI is not powerful, it has to have guidelines. There was a third code that I showed in the first day. That was from Sam Altman, the founder of ChatGPT. He basically said a lot of guys realizing that there is to be some kind of guardrails with respect to AI, and those guardrails will be coming. So in terms of what I'm looking at it, I have a variety of investments, some various aspects, but very verticalized. So I have a company which is using deep learning, has got 50,000 claims, all codified, and when insurance companies get a new claim, it basically goes through a simple process and says, how severe is this claim, what is the potential that a lawyer might be involved in litigation, and the insurance companies use it to gauge claims. Otherwise, they spend a lot of time looking at the huge volume of claims. For them, it's very valuable to understand how complex is a claim. And this is all done in natural language. These claims are all there in some code, but a lot of it is lots of reports. Another example of a company that I'm interested in is it looks at very complex documents, PDF documents, and takes that information in there and puts it into a database for data processing. Typically, the first use case was customs brokerage, where you have huge amounts of forms, very critical to supply chain. Products come through. Today, that work is done with humans. It takes anything like 10 days, reduced to few minutes, done with AI applied there. Another use of it that the US wouldn't like to hear is IR is a big customer. They're actually using it because they look at forms and then look at for fraud detection. Another example of AI in medical is they are automating surgical workflows, streamlining surgical workflows. They write pre-patient, post-patient, during the operation and post-operation. Companies in the VA, automating a different variety of Veterans Administration hospitals with this AI workflows. Another application is video surveillance. So video cameras for two purposes. Today what happens is we have a lot of video cameras all around. But and even in India this is the case, it's all the CCTVs. It's a very human approach of looking at what's happening there. We have monitors, a huge number of monitors and people staring at the security guys in there. The AI actually doesn't need that. It actually detects movement, detects a person, detects cars, and even detects things like loitering. Someone is there, it knows what's a loitering behavior and is able to highlight that. So all of these are vertical applications of AI. Amazing. I'm hoping, and again, we are investing early, hoping something comes out of all these. But it's fascinating to hear all these entrepreneurs talk about what they're doing. So, generative AI, that's just the canvas. All the values and applications. I heard some great applications in the medical panel, and I'm sure you're going to hear from some of the startup pitching. Easy hanging fruit right now is content creation and marketing. I mean, really content writers and marketing managers will, if they don't change, they're going to lose their jobs. A lot of work is getting automated. I've already talked about medical transcription, that was mentioned, that has already gone long time back. AI being used for medical transcription there. Interesting enough, software engineers, if you don't watch out, will start getting replaced by AI because now there are co-pilots for software which recommends snippets of code for any application, correct your code, make it more efficient, all sitting as a co-pilot along with you. And of course, in terms of healthcare, there's great applications of protein discovery, which has been done with AI, where they're going through all the different sequences and trying to figure out where are the new protein sources available there. The new thing which is happening is agentic AI. The best way to think of it, it is your alter ego and a clone of yourself acting on your behalf. Autonomous vehicles is a car example. How many are sitting in a self-driving car? The car is driving for you. Well, the car is your agent. Okay, it is working as an extension of your agent. Customer service is becoming more and more like that. Healthcare also is getting there. I mean, someone had mentioned IBM Watson Health. IBM Watson Health is an example of agentic AI, and it will get clever and more improved as time goes on. So, where are we now? Don't fear AI. It's not an IOO moment, it's a wow moment. You really have to embrace it because there's a lot of things going to help. There are going to be guardrails that are set for AI, this is going to happen automatically. But I think we'll all learn and we'll all extend ourselves. Now, I would not have, as Hari mentioned, I would not have given all this talk in the old days. To give a talk like this, I would have gone, talked to 15 people, spent 2 months trying to do the research. I actually used AI for all of this. Okay. Starting from the point that said, give me a presentation template that I can use for a bunch of DB school guys to talk on AI. No, I didn't mention DB school, but I definitely did say a presentation of AI talk. I used ChatGPT, I used Perplexity, which is an enhanced version of like a top of something like Google search. I used DALI, all the images I didn't create, it was created. But again, that's an example of what it is. You have to practice what you preach, and that's really the power of AI. So it's a great time, I'm enjoying it, and hope stimulate all of you to enjoy the growth of AI. Thanks.